Okay, I think we can probably get going. We've got almost everybody in who I had on the registration list, so we'll go ahead and start. Welcome everybody, thanks for joining us on this warm Tuesday morning. This is an introduction to the B3 guidelines, the SB 2030 small building method. And I'm Pat Smith. I'm a senior research fellow at the Center for Sustainable Building Research at the University of Minnesota, and I help to manage the B3 guidelines in the SB 2030 program. Joining me today is Dee. Dee, if you'd like to introduce yourself.
Sure. Thanks. My name is Dee Sui, and I'm a research engineer from Center for Energy and Environment. We've been doing this SB 2030 review for, well, almost 10 years. I've been doing this for like 7 years. That seems to be a pretty long time. And yeah, thanks for inviting me, and thanks for everybody for joining us today.
I'll just go through what we'll get through today. This is an hour-long presentation and Q&A period. Just start with the logistics, the webinar education credits. I'll talk a little bit about the goals and the backgrounds of this, the 2030 small building method. Looking at kind of taking a step back and looking at how the SB 2030 program is structured, particularly post 2020, when we made some program modifications to allow on-site and off-site measures to be brought to bear for projects compliance. And then walking through specifically how to use this prescriptive approach. Dee will talk a bit about the applicable standards that are options for folks to use. I'll talk about how to do target setting and how to evaluate or estimate your design energy consumption. And then looking at stepping outside of what can be done with efficiency measures and looking at renewable energy and then what those different supply options are. And this matches the hierarchy that we use for larger projects. And then we'll go back and talk a bit about what we'll be looking for in the review process. So when you submit, what should you be double checking that you've both included in the design and in the documentation of your projects. And then we'll leave time at the end for Q&A via the chat. Okay, so for logistics, we do record these sessions and post them on our training page. That's at b3mn.org, and you should see a training link there. If you need AIA credit, please drop your AIA number into the chat, and we'll collect that when we wrap this up and submit that to the AIA. If you self-certify, if you're an engineer or other discipline that needs a certificate of completion, those are sent after the meeting. And please let me know if you don't get those, by next week. We do look to send those out. We have the attendees on mute, but we will be keeping an eye on the chat and the Q&A. To make sure that we're addressing questions. We'll do some of those as they come up. I'll keep an eye on that for those, and then at the end we'll leave time to loop back to make sure that we've not left any out there that folks have questions on. I did have one question that folks can respond to in the chat. We did try to include in the registration link with our University of Minnesota registration system the link to be able to register for this webinar, but it doesn't look like that everybody got that. So I both registered everybody I think yesterday, and then also sent out registration links to everybody. But I'm just curious if folks were able to see that when they first registered for the webinar, or whether that wasn't an apparent process, because it seems like it's still a little bit clunky. Yeah, so there's a question in the chat about, can you send your AIA numbers to the registrants if you're cautious about sharing that to the group? Yes, you can. There is an ability to when you open up the chat, you can send it to panelists or all panelists and attendees, and so you'll want to select all panelists for that. Okay. All right. Looks like we do have some of those coming in, so that's great. Okay. So what are the goals of the SB 2030 small building method? The intent is to provide a path for smaller projects to more quickly walk through the minimum efficiency needs of a project as part of their bundle of measures needed to meet to hit their SB 2030 targets. It also provides projects with prescriptive options, which we know that some design teams that are have a limited amount of time to spend on projects do basically want a list of things to proceed with that's clear and concise, and they can just take and move forward with. Also, this enables projects to move develop more quickly the need of renewable energy in order for projects to hit their SB 2030 target. As we move from 70 to 80%, renewable energies is an increasing part of the measures that are needed to be brought to bear to hit these more aggressive targets. And so finding out how much that is, what the scale of that is a very useful thing to get up in front of project teams early, so that you can all kind of level set on the same kind of amount of that resource. And all this is to also decrease the cost and administration for smaller projects, to be able to get them more quickly through the program, but also in meeting these program goals. Related to this, and these are very similarly named, we want to flag that there is a related process under the B3 guidelines program called the small building method as well, which looks to winnow the number of guidelines that we apply to smaller projects, and with a similar square footage cutoff. And this is for similar ends, right? We're also trying to decrease the cost of administration for those projects, and we pursued this this path creation with the intent to focus on those higher impact items. Particularly for those smaller projects, where it might make less sense the amount of time it takes to meet a target, or to do the analysis to find out if you are meeting a guideline. If you are in one of these smaller projects, potentially the smaller design team, smaller budget, and just smaller overall level of available effort to put towards this. So this is up and running in version 3.2 of the guidelines, and we are currently getting the final items in the tracking tool updated to accommodate this. Most of them are up and running, but there's a couple that are still not quite implemented yet in the tracking system. If you do have a project that is interested in pursuing the B3 guidelines small building method, again, only under version 3.2 is this available. Please drop me a line if you're not already kind of in that path. We do let projects move into a more recent version of the guidelines. And if you have a project that might be starting out but under 3.1 or earlier, it might be worth looking into taking advantage of the small building method. Okay, so when the applicability of this process, applicability of this small buildings approach, the general rule is less than 20,000 square feet of gross conditioned area. And this size does align with our threshold under the B3 guidelines small building method. Also aligns with some utility program cutoffs and the ASHRAE small building design guides. We're also using this 20,000 square foot threshold for renovations and additions. So if you have a wing of a building that you're doing a renovation of and it's under 20,000 square feet, this path is also available to you, even if the overall building, including the area that you're not touching as part of the project, is greater than that. I'll note also that there's a 10,000 square foot minimum renovation cutoff for pure renovations for the state, triggering the state requirements. And so the smallest renovations generally aren't coming in under the program. Note that there is some distinction with these two parallel programs around which space contributes to this 20,000 square foot cutoff. We look at generally a broader amount of square footage under the SB 2030 program than we do under the B3 guidelines program. So the occupancy really drives for the B3 guidelines, whether you're including the square footage towards the 20,000 square feet for B3 guidelines, whereas we're really looking at conditioned space, even if it's semi-heated for SB 2030, because it really is an energy program. And so we look at occupancy for all the IEQ things under B3, and for SB 2030, we're really looking at how much heat you're putting into these for conditioning. So these are the categories that would contribute to SB 2030. Whereas note that there are several within here that are potentially excluded from consideration for the B3 program. Our intent was for semi-heated storage and other non-occupied space to not include that towards B3 guidelines, but that would go towards SB 2030. Okay, so just taking a quick step back, B3 guidelines and SB 2030 are part of a network of programs that come into play with buildings design, construction, and operation. B3 guidelines and SB 2030 come in starting in pre-design, move through the design and construction, and then carry on through operation. And operation there picks up a couple of other arms of the program, including the post-occupancy evaluation process, energy efficient operations, and then the B3 benchmarking program, which can also be used for those projects that are not part of a design and construction effort, but just are in operations alone. We've got I think it's about 8,000 buildings in the benchmarking program at this point. Question for whether this table, I'll go back one slide just to pick up this here. Is this table specific to small building method? Was a question from the chat. This table is which square footage would contribute to that 20,000 square foot cutoff. And so this is both for the small building method under B3 guidelines, but also the small building method under SB 2030. It's not, if you had a space, I think this is getting to your question. If you had a space that was part of a building under code and not conditioned, it would still need to meet the B3 guidelines program, but it could do so with a small buildings approach. So this isn't a table that would permit a project that would otherwise need to follow the B3 guidelines program, not follow the B3 guidelines program, but instead it's intended to sort whether those projects can follow a small buildings path or not. And I hope that answers your question. Okay, excuse me. SB 2030, again, we're kind of moving at this, we're stepping back and looking at this from a top level. It's a progressive energy and carbon reduction program. It's modeled after the AIA 2030 program, but it's customized for Minnesota's buildings, climate, and specific policies, because we are essentially operationalizing policy from the Department of Commerce. We've also expanded this to allow the inclusion of more building types than we feel are well supported under the Architecture 2030 program. And so we are, if you are looking at the reduction scheme, looking at a 2003 average building, we are now at an 80% reduction from that 2003 average building, and that is written into the originating legislation. We use a couple of tools to track projects' progress through the programs. We use the B3 guidelines tracking tool, where design team members can all have access to the same file and the same set of requirements. They can go upload documentation, verify compliance, verify that they're meeting the metrics that are laid out before them. And then specifically for SB 2030, we have the energy standard tool. And so this is a model that permits projects to set their energy target and also permits them to do a design evaluation if they're using the as design part of that tool. And so these are both housed in our online tracking system and are accessed by the design team members. Getting a note that my audio is coming in and out a bit. Apologize for that. I will tweak my geometry towards my microphone. Hopefully that will improve things. Let me know if that continues, and I'll continue to focus on that. Question about how a seasonal use building is treated with this within this program. So the energy target for that building would be set based on that seasonal use. So you would see a pretty low number in terms of energy use, both for the baseline, but also for the for the reduced case. So we do have the ability to set those seasonally dependent schedules within the tool. The digging into the actual language of the legislation behind B3 and SB 2030 looks at part of the definition is if you have a new construction building, whether that's a building under code. And so we do have some of these buildings that that are pretty minimal in terms of their what they are. They're seasonal or they're quite small, but we don't have a kind of a carve out to exclude those. We do have an approach where if you have, let's say, a building that does not have any indoor environment, it's not enclosed, we can trim out things like your indoor air quality items because they're just not relevant to the project scope. That's done with a discussion with the CSBR, with the program administrators, to document that there are guidelines that it's not a question about whether they're being met or not. It's just they're not relevant to the overall scope of the project, typically as it's described in the bonding bill. So if you've got a project, another example of this is if you've got a project that's an interior only renovation, we would do a scope determination with your project for those items that might be related to landscape design or stormwater management that would take those out of your B3 guidelines list. So so the seasonal building question would come into play with potentially with some of those scope determination, but also in terms of the way that we would set the target, again, based on that more minimal use, that more seasonal use. Okay. So this tool creates this 2003 average building. That was the big yellow bar in a couple of slides back. But it does that based on the program that's input, based on what you're actually going to be doing with your building. So it takes a look at setting a different target for, let's say, warehouse than it does for a lab building, because it wouldn't be reasonable to set the same target for those dramatically different energy uses. So what this is tuned to align with the Architecture 2030 baseline approach, but it is a modeled baseline. So it does permit much more flexibility in terms of this target setting exercise, including, to the last point, setting this for buildings that might be seasonally occupied, which would not be well represented in the data set that Architecture 2030 uses. Generic overview of a project's path through the program. So during pre-design, you'd set this energy target. Again, that's based on that reduction scheme that I previously showed. We've got presets loaded into the tool that represent basically our best estimate for what a typical building of the type that you tell it is using. Then that becomes the energy target for the project. That becomes the preliminary energy target for the project. This gets refined through schematic design, design development, and through what we call final design of the tool, but really is wrapping up CDs, where this design team submits a energy model confirming that they've hit this energy target. And then we review that. Along the way, typically at what's called the design phase submission, and then at the final design to confirm that the energy target is appropriately set and confirm that the design team is meeting that. And then during operation, this target, this energy standard remains and is referenced against the project's operational energy use. Couple of kind of framing notes. We did update the program to include reference to carbon intensity alongside energy. So this is both an energy and a carbon reduction program. But the landscape of the improvement of the utility grid, the electric grid in Minnesota, is such that the energy use is the operative goal for the vast majority of projects in the state. So very rarely will it come up that the the carbon goal will be harder to meet than the energy goal. So this is framed around the energy requirement, but be aware that we do track carbon as well as energy. We are now at an 80% reduction from that 2003 base case, which is a significant shift. It's a lot of it's a big reduction in energy use. This is not equivalent to say it's an 80% reduction from current code, because current code has also progressed since 2003, but there still remains technical limitations to achieving a 80% reduction with just energy efficiency measures alone. The graph at the right shows a smattering of payback evaluations under some Midwest EDA programs, and shows really a boundary there for how aggressive folks were getting with their payback and how much reduction in energy use they were achieving. And so you do see this this kind of barrier at at what participants are hitting, and if we're taking an estimated 2030 target for a building for an office is about 20 kBT per square foot per year, so that's 20 energy units per square foot per year. You're seeing a limit to how close folks are able to get to that. So that then brings up the discussion around what other measures can you bring to bear to still hit these targets, because we do still at the end of the day need to hit these increasing SB 2030 targets and move towards net zero for projects that are coming on board. So renewable energy is going to be a piece of this, where renewable energy is going to be increasingly needed to hit targets. And then as that comes into play, there's also the question about where that renewable energy should be located. And we've put forward a hierarchy of evaluation and implementation of that based on National Renewable Energy Lab classification. We also have more often cost effectiveness coming into play with these 80% better buildings. In terms of cost effectiveness, how we treat cost effectiveness. So initially, when we first booted up the SB 2030 program, we looked at, we being CEE and the engineering group there, D and Russ, looked at utility style cost effectiveness evaluations, because that's what the legislation that created SB 2030 tells us to do. We looked at these utility style calculations and methods within them, notably the societal test, participant test, and utility test, to find out what level of efficiency could be considered to be cost effective. The initial run of this, we looked at over 100 buildings and a bunch of conservation measures, and landed on a test of 15 years simple payback as the limit to what we could consider to be cost effective. And so that is if an individual measure comes back within that payback period. And so that becomes essentially the window of efficiency that we can ask for under the program, is that 15-year payback. Updating this in late 2019, we shifted that to a 12-year simple payback, and that was in large part due to improvements in the grid. The grid is cleaner, and so there's less impact to using a little bit of additional energy, so the payback window then shrinks a bit. So we now operate on a 12-year simple payback for those folks that are using the 2020 or more recent SB 2030 standards. And so it becomes a way to essentially proxy this complicated utility style cost effectiveness evaluation with a simple number that design teams can test things against and can operate within. So that 12-year payback is our kind of operative payback window right now. So projects that bump up against that, projects that don't have available technologies to hit that 80% target, would then need to bring renewables to bear to make it the remainder of the way there to their energy target. For where to look for these this renewable energy, we used a classification system developed at the National Renewable Energy Lab, looking at this hierarchy from on-site to off-site. And we did a little bit of tweaking of this for some considerations present in Minnesota's SB 2030 buildings. So this is on the left shows the NREL breakdown of the different supply side options and then where they fit in the hierarchy for SB 2030. The top three are efficiency measures, on-site renewable energy, and on-campus renewable energy. Those three are equivalent under our program. And so and can be essentially interchanged. So if you are pursuing a less efficient building with more renewables associated with it, those can be essentially fungible under our program. The item number 3, which is our second level in the hierarchy, this is the blue box, is if you have in portfolio opportunities. So if you have, and this is particularly relevant for those state agencies that might have non-cost-effective smaller renewable energy development, but can do a larger chunk of that somewhere else. That's intended for that second tier of the hierarchy once you've exhausted what you can do on site. And then the third level is if there's not, if you've exhausted your measures on site up to that 12-year window, you've exhausted your measures on your portfolio up to that 12-year mark, then the remainder can come in with renewable energy credits. Just a note here where code is in relation to this. I mentioned that that's 2003 average building is, we're not looking at an 80% reduction from 2003 average building because we are looking at 80% reduction from 2003 average building. We are not looking at a 80% reduction from current code. Current code is somewhere in the 47, 48, 49 range in this ZEPI index, where 100 is that 2003 average building. We're about halfway to zero from there with current code. We are still seeing there's not a non-trivial reduction still from there to where we are with SB 2030. So how this looks when you look at what efficiency measures are brought to bear and what renewable energy measures are brought to bear, there's several different essentially buckets that project teams would need to pursue. So if you have here your 2003 average building, this is our base case. We're now at an 80% reduction from that. Current code sits at about a 50% reduction from that 2003 baseline. Efficiency measures above code would take you down some of the way, but if you're depending on your building, might not take you all the way to the 2030 target. So then you have an amount of energy use based on just energy efficiency measures. Then looking at potentially bringing to bear on-site renewables, again, exhausting those on-site or on campus if you've got a campus to work with. And then we do a thing called setting an on-site target with everything, basically the kitchen sink, cost-effective on-site, and then the remainder coming in with in-portfolio development or renewable energy credits. So that's the IPRE is in-portfolio renewable energy, and then RECs are renewable energy credits. So small building method of this broad set of things that SB 2030 asks, it helps set these efficiency measures. It takes the place of what is typically a back and forth with the review group about what can be considered cost effective and what falls within that window, and uses one of these prescriptive approaches to do so. And is intended to, in some cases, limit the need to perform energy modeling and in particular do cost evaluation. We still use the 2030 standard tool, and then it's been updated this as part of this process to include prescriptive requirements, renewables, and offsite options. I'll note that we have posted this method on our SB 2030 website. So if you go to b3mn.org and click on SB 2030, this process is laid out in a draft document. I'm expecting later this month to be able to put out the final version, but I wanted to get the draft up so folks have something to reference if they've got questions after today's discussion. All the parts are there. It's just we need to do a little bit of wordsmithing and add a little bit of clarification. There's 5 parts to this method. You establish a target, you implement your efficiency measures, you estimate your energy use, and then implement on-site renewable if you're not all the way to your target without it. And then stepping off-site to look at if you have in portfolio development opportunities, or if you have, or if you're skipping over that, going to renewable energy credits. Setting the energy targets done with the energy standard tool. Project teams input their building characteristics. This produces a 2003 baseline. So this is the thing we take the 80% reduction from. We do that with the same use, function, building characteristics, airflow rates, process loads, those things that influence the energy consumption of the building. We capture those and then set your target based on that. This tool also has the ability to do some embedded energy modeling if you are looking to use it to evaluate your design. We also have an as designed model, which uses the same energy modeling engine as the Willdan uses for its EDA process, and Willdan uses for their that energy optimizer tool. This is picked up in terms of what's called space asset areas, which are programmatic blocks of a building. And so rather than looking at carving out square footage of bathrooms and associated mechanical rooms and every individual office space room by room, this looks at broadly what are the programmatic square footages and uses those to construct the building, which lets project teams get their target a little bit more quickly and then be able to more quickly have that understanding about what they're going to need to hit at an early design phases. Excuse me. And then part two is the building performance standards, and I'll hand it over to Dee for walking through what we're asking for in terms of specific building standards.
Thanks, Pat. So the next step will be to implement the energy efficiency measures, which means that the project team needs to select from a number of standards and to prove that all the requirements are met. So those requirements basically cover the design of envelope, electrical and mechanical systems. And besides those, SB 2030 also, or in general, also requires providing a metering plan, which we will talk about that later. And next slide. So this page has all the options of standards that a project team can choose from. And for commercial buildings, we have 4 options, and for residential buildings, we have 2. And we will step through each one of them from the next slide. Starting with commercial buildings, the first one is ASHRAE 90.1 2019 version. This is probably the one that most people are familiar with. This standard has 11 chapters and focus on different part of the building design. The screenshot here shows a typical compliance path for one chapter, and you can find it on the first page of each chapter. The projects are required to follow the prescriptive path, which means that they need to meet all the requirements in the sections circled out in this screenshot. And there are the 0.4 sections, mandatory provisions, 0.5 sections, prescriptive path, and 0.7 through 0.9 sections, the submittal products and inspection and verifications. Next slide. So the first 4 chapters are basically talking about the scope of work and clarification on the definitions. So the actual requirements are listed in chapter 5 through chapter 11. And this table on the slide here, it shows the key requirements that we focus on during our review, since they have a higher impact on building energy use. Next slide. So moving on to the second option for commercial buildings, that is the New Building Institute 40% stretch energy standard, well, which is also called the NBI. And we are following the path B, which is the prescriptive measures. Next slide. And under path B, which is pretty similar to ASHRAE, there are 6 groups of requirements, and each group focuses on one part of the design. The list here shows what those 6 groups are and the number of requirements under each group. There are 2 additional rules that we need to pay attention here. First of all, if you choose to follow this standard, the projects also needs to meet the ASHRAE 90.1 requirements. We have a list of the additional ASHRAE requirements that needs to be followed, and it is included in the small building guide, which you can find on the network that Pat just mentioned. And the second rule is that when a requirement in NBI references the ASHRAE 90.1, we want to make sure that you're referencing to the 2019 version. And Pat, do you want to make any comments?
I was just going to underline that all the commercial options here are either the base ASHRAE 90.1, all the options except for the ASHRAE Advanced Energy Design Guide are based on ASHRAE 90.1 2019. Even if the method that NBI or IGCC might reference 2016, we want that 2016 to be replaced with 2019. So you're going above 2019. So that 2019 creates that floor again, except for the ASHRAE Advanced Energy Design Guides for those different options.
Yes, exactly. Thanks. So with those two rules, we can move on to the next page. For the third option, which is the International Green Construction Code, which is also called IGCC. This one looks a little bit more like ASHRAE. All the requirements are listed under Chapter 7, Energy Efficiency, and the project team needs to follow also the prescriptive path, which means to meet all the requirements under Section 7.3 mandatory provisions and 7.4 prescriptive path or prescriptive option. Next slide. And as Pat just mentioned, same as NBI, the project team also have to meet all the ASHRAE 90.1 2019 requirements. And a list of those additional requirements are included in the guide. And also, if the standard is referencing ASHRAE 90.1, make sure to reference to the version 2019. So there's a question on NBI. If NBI is 90.1 plus NBI, why there's also an option for just the plain ASHRAE 90.1. So if you're following the NBI, later on, Pat will explain on a multiplier that will actually, as a way of calculating how much renewable energy you need to meet. So if you're following NBI, there will be less required renewable energies, but less than just the ASHRAE 90.1.
Yeah, that's exactly right. You'll essentially have to bring in less renewable energy farther on the efficiency side. And so we wanted to make the 90.1 available because it's so broadly applicable, but wanted to have a couple of notches above that if folks wanted to push on the efficiency side and then see a reduction in the necessary renewable energy side. But I'll get more into that in a couple of slides.
And then going on to the last standard for commercial building, which is the Advanced Energy Design Guide, Achieving Zero Energy Ready series. For this series, it includes two standards, one for small to medium office buildings, and the other one is for K-12 school buildings. And the requirements are all listed under Chapter 5, which is called How-To Strategies. And there is a table at the beginning of the chapter that lists all the requirements and the locations of the requirement details. Next slide. The AEDG has more requirements compared to NBI and IGCC, but the thing is you don't have to follow the additional ASHRAE requirements. Yep, next slide. And Pat will talk about the standards for residential buildings.
Yep, so for residential buildings, we're asking for certification under the Zero Energy Ready Homes program or one of the two passive house programs. And because these programs actually include energy modeling as part of them, we will be accepting the energy model that comes out of those processes in order to do this exercise of determining what the renewable energy needed after they've met those efficiency measures, what that is. So unlike some of the commercial options where project teams would come through without energy modeling with some design consumption evaluation estimates that we'll walk through how to do, the residential ones will be pulling the model to come out of that process. Question in the chat was, what about the new FIAS prescriptive path? Because we work within a 12-year window, the passive house generally gets a bit outside of that. They would be more aggressive as a baseline then we would be able to ask for under the SB 2030 program. I will admit not having evaluated the FIAS prescriptive path, but if it's in line with the level of performance that FIAS is getting with the with their typical approach, then it's likely able to be used for for compliance. And then thinking a little bit more about your question, you're likely asking, do you need to model that if you're doing a prescriptive path? That's a question we can work through. If there's a project that wants to pursue that, we can look at if there's a way to estimate the consumption of that project. So likely wouldn't be an issue, but we need to do some thinking about how to process that. It's a good question. And then Dee, do you want to talk about the mandatory efficiency requirements that are alongside these other ones?
Sure. Yeah, besides meeting the standards for residential buildings, you also have to make sure that the applicable equipment are meeting the Energy Star certificate, and those are we have listed all the equipment that needs to follow that standard. Yeah. And for water fixture itself, those following type of plumbing fixtures needs to meet certain design flow rates requirements, and that includes two different type of faucet and the shower heads.
This is a bit higher. We went a bit up on the shower heads than we were in the prior version of this method, because there's apparently like a broader amount of products available at a higher threshold. Okay, so then you've selected, as a project team, you've selected which prescriptive approach that you want to pursue. And the question now is, okay, well, how much energy is this thing expected to use? And there's a couple of different methods to determine that. One, and the most straightforward, is to run an energy model for this. You can run this with Trace, IES, with any of the modeling tools that we accept under the program. You can run this in the as design model, the one that's actually included in the Energy Standard tool. And what this and you'll run that with the measures that are included in that prescriptive approach, and anything more aggressive, anything higher performance that you want to include. What this does allow project teams to do is to take credit for those items that are better than your prescriptive approach baseline. So you'd get a number out of that, you'd get an energy use intensity out of that process, and then that would compare to your SB 2030 standard. You're likely above that. And then you've got on-site renewables and off-site renewables to step through to meet your energy target. The second option in determining how much energy use your building is expected to use is to apply a multiplier of the SB 2030 target based on your building type and based on your selected standard. Since you're selecting a more aggressive standard, there is a smaller multiplier moving from your SB 2030 target to your expected performance. And so this is taking this the number that would come out of the Energy Standard tool, and multiplying that out by, it might be 1.6, it might be 3.0, it might be 0.6, all depending on on how aggressive of standard you've selected. And then the same part of the process would step forward, where you'd be evaluating on-site renewables, implementing those, doing as much as you can on the site before then looking at moving off-site if needed. The multipliers vary quite a bit between which targets being selected. And note here, the AEDG, these Advanced Energy Design Guides, get you the farthest amount of the way there, especially on secondary school and primary schools, where you're actually under the SB 2030 target if you select an Advanced Energy Design Guide without bringing on any renewable energy. I will note that the Advanced Energy Design Guide, the AEDGs, are the net zero energy series, not the previous 30% better or 50% better. These are just for those most aggressive tier. And I believe more of them are going to be made available, but right now that's just for K through 12 schools and for small to medium offices. You also have, if you're a secondary school and you're using the IGCC, there's sufficient efficiency measures there, again, without bringing renewables on, that we're able to consider that compliant with SB 2030 because of its the measures that are included. Warehouses are particularly tricky, so we're not getting to 2030 targets or particularly close with these measures, but they are still available for project teams. This is in part because they're lower energy use intensity. I know some of you are likely thinking, well, what if I've got a building type that is not on this list? That's one that we need to discuss and see if there's one that's reasonable, a multiplier that's reasonable to apply in that case. Liz noted the ASHRAE Advanced Energy Design Guide site in the chat if folks want to look at what that, see what that looks like. Okay, so then you've got the remainder. You've got your target, you've got your efficiency, what level of efficiency you've achieved. And these graphs are in terms of energy use intensity, so this is energy per square foot. So you'll need to bring in some renewable energy to make it the remainder of the way there to your target. On-site is the most straightforward, and on-site includes on campus, if you have a campus to work with. And that renewable energy needed is just the estimated energy use minus your SB 2030 energy standard. So if the sufficient renewable energy isn't feasible on the site, the request to design teams, the way to frame this is you want to maximize the system size within cost effectiveness. So you might be able to get a little bit more energy out of a renewable system if you up the panel efficiency, but if that kicks you outside of the 12-year window, we're asking for that system to be maximized up to that 12-year window, which for some projects does include a robust renewable energy development on site in order to offset that demand. So this renewable energy will vary depending on how far you got with your efficiency measures. So these are not to be used to say, okay, well, if I've got this building and I'm using this standard, this is my KBT per square foot of renewable energies, because that will vary with how you set your energy target. These are examples of our baseline modeling, how much energy is coming out of these. So these are fairly significant, right? These are not trivial in terms of the amount of renewable energy development that will be needed. A note on renewable energy credits. Renewable energy credits are essentially the ability to claim renewable energy use rather than just the electricity that's coming off of those panels. You're actually be able to claim the fact that it's coming from a renewable source. We understand that some projects may want to avail themselves of utility programs that assist in the procurement, the development of renewable energy, but those programs also include the sale of those renewable energy credits to the utility. That's permissible under the program and permissible to account for on-site measures as long as you replace those RECs. Those RECs can sometimes be replaced at a lower cost than you sold them for. So this is a somewhat fussy process called REC arbitrage, but we wanted to put it in place in order to make projects able to access those programs and also to stay within our Department of Commerce rules, where you really do need renewable energy credits to be able to account for renewable development. So you don't have SB 2030 asking for solar development while that's being double counted with Excel's portfolio requirements. So the remaining energy, once you've exhausted your site, you'd be looking at portfolio development or renewable energy credits. So we understand that different organizations have different portfolio opportunities. State agencies will have a different availability of this than will a one-off residential building. But those are the last bucket, the last area to use for hitting your SB 2030 target. The question was, what resources or data informs the 12-year simple payback period calculations? You'd be looking at typical utility rates in a market. Would be the energy, would help you calculate the savings, and then looking at the at cost data either from our baseline cost model that we have loaded into our energy standard tool, or pricing from contractor. The question was, would I share this slide deck as well as recording with the participants? Yes, that should be up likely this week on our training page as well. So we'll put a PDF of this up. Yeah, should be yet this week if Liz can confirm that. Next week, I think she might be out after this. I'll hand it back over to Dee to talk quickly about what we'll be looking for in the review process.
Okay, so I'm going to talk about the documents we're looking for the commercial building reviews, and in the next slide, Pat will talk about for the residential buildings. So we mentioned earlier that those requirements covers the architectural, electrical, and mechanical designs. So basically all construction documents that contains the design details are required. And the most common ones are drawings and specifications. And sometimes some of the design details are not included in those two documents. So we would need additional construction documents such as the submittals or spec sheets of the selected equipment that are also required. And information that we mostly see that got missed are like exterior wall and roof assemblies U factor or insulation R values, and also U factors and SHEC of exterior window assemblies. And information on duct ceiling information, they should be included in the specs, but sometimes they're also missed. And also the specifications needs to have this narrative on there will be a lighting system functional testing. And sometimes we do see like HVAC equipment efficiency that are also not marked in the mechanical schedules in the drawings. So either a model number, or if you want to submit a spec sheets, that will be great. And besides those construction documents, just SB 2030 also requires all projects to provide a metering plan. And the goal of this plan is to make sure that the meters measure all and only the energy use of SB 2030 scope of work. And the readings will be recorded at least monthly and will be uploaded to the benchmarking tool. So, and the details of the metering plan requirements are also included in the small building guide. And the last part of the documents required are for renewable energy. So project teams need to provide documents to justify that they meet the renewable energy target. That includes, if for on-site renewables, the narratives, bids, and necessary calculations. And for the off-site renewables, the documentation of in-portfolio development or the REC procurement. That is for, oops. I think Pat just got cut off. Pat, you're on mute.
Apologies for that.
It's okay. I just finished this page, and if you want to go on, okay.
Projects, what we'll be looking for is essentially confirmation that you're complying with the FIAS Pass International or the Zero Energy Ready Homes program. So we're accepting that documentation from that program. It does require that you do achieve certification. It's not achieving equivalent measures. It is actually achieving certification. So we will be looking for that. We'll also be looking alongside that for the evaluation of the renewable energy needed to bring to bear, and then how that's being met. So this looks like, okay, well, here's my target. Here's how far I got with my efficiency. Here's the remainder, and here is the evaluation and sizing of the on-site solar, and then the remainder coming from off-site RECs. And we are very close to time. I was thinking we'd be quicker through this, but I will pull up questions if there's any in the Q&A. I did because I popped off for a second, my Q&A disappeared for the ones that had been asked so far, although I do remember one person asked whether the cost model is available for project participants. Yes, you have a default cost model that's regularly updated, that's within the as designed tool, within the SB 2030 Energy Standard tool. And so that does give you an idea up front of what measures might come in as cost effective, what measures might come in as needed to bring to bear to projects. And so that's available for project team participants or project participants for small buildings or larger buildings. I hope that answers your question. Liz, sorry, go ahead.
There was a question just a bit back. What resources or data informs the 12-year simple payback period calculation, please? Thank you.
Yep, so you'd be looking at your utility territories utility costs as a for evaluating what that savings is for a specific measure, and then you're looking at energy model for determining how much savings you'd actually achieve from a measure. And that is for larger projects. Again, for smaller projects, instead of doing a measure by measure cost-effective evaluation, we're letting them proceed with one of these prescriptive approaches to skirt that back and forth process of finding that 12-year payback bundle. So the 12-year really comes into play only on the renewable side for smaller buildings if you're using one of these prescriptive approaches. I see something on the chat. Okay. The question in the chat was if a project pursues energy modeling option using the online analysis tool, is the project still required to meet the prescriptive requirements of ASHRAE 90.1 2019? If you pursue energy modeling, I mean, I'd have to meet code, but if you're pursuing energy modeling and we're working with your project to determine what that 12-year package is, then you wouldn't also need to meet the ASHRAE 2019, ASHRAE 90.1 2019. You're likely going to get a bit more aggressive than you would with an ASHRAE 90.1 2019 if you're pursuing that approach, but it's not required. This is intended to be a method that's available for smaller projects, but not required in lieu of a full modeling effort. So you get more flexibility with that approach if we're setting your set of measures up, but it's more determination of what's needed to be brought into that. Hope that answers the question. A question about if a hypothetical project example where it's a mechanical equipment, air handling, and roof replacement, how can savings be achieved accurately? Concerning the aspects of internal load and shared hallway spaces. Would be looking for plausible analysis of how that would all knit together. Understanding that you might not have full accuracy in terms of existing assemblies, full accuracy in terms of shared load. So yeah, it would be a question to tee up for our review group to say how would we want this to be treated. And even if it's as simple as, okay, well, in the time this project was built, here's typical wall assembly as a place to start with, let's say, R value. And I will say that there are some projects that are very minimal in scope, especially those that do not include mechanical replacement, that upon review by the Department of Administration may be excluded from the program. Again, that's typically for those projects that might be, patch and paint or not include HVAC or enclosure renovations. I know we're at time. I'm able to stick around for a couple minutes to answer any remaining questions, although I don't see any in the chat unless I missed some while I popped out with my technical difficulty. All right, well, thanks everybody for attending today.